Today's goal is we want to be able to convert vectors. And specifically, there's two things we want to accomplish today. If we ever have a vector that's written in rectangular form, we want to be able to convert it into polar form. It's like a quick example of that. If we have this vector 3, -2, here it is in rectangular form, and we're able to draw it on a rectangular graph. You're going to learn today to be able to convert this from a rectangular graph, rectangular coordinates, onto a polar graph with polar coordinates. Okay? So that'll be the first thing. Now the next conversion we're going to do is the opposite. We also want to be able to do, if we ever have a vector in polar coordinates, we want to be able to convert that to rectangular coordinates. So for example, if we ever have a vector, here the coordinates are a magnitude of 5 at an angle of 60. Okay, so it would look like 1, 2, 3, 4, 5. If we ever have a vector in polar coordinates on a polar graph, can we convert it into rectangular coordinates in a rectangular graph? So the first thing I'd like you to do is hit pause on this video. Start by just copying down these formulas. You're going to need all of these formulas to continue. And I'll show you, while we do the examples, I'll show you exactly what these formulas mean and where they come from. But right now, just hit pause, write these formulas down. Okay, so we're going to do an example first. This formula here, converting from rectangular to polar. So let's look at our example. We have this vector u with the horizontal component of 3 and a vertical component of -2. You can see how it falls down here in quadrant 4. Well, let's convert these into polar coordinates, and let's start with the magnitude. So here's the formula again. I'll write it out one more time. Okay, in essence, what we're doing here, we are turning, really to find the magnitude, we want to find the distance of this diagonal. How long is this diagonal? Well, really what we're doing is, in essence, we're just turning this into kind of an invisible right triangle where this is a 3 and this is a -2. And guess what this formula does? This formula just does the Pythagorean theorem. Okay, to find this, we take the square root of 3 squared plus -2 squared. This is really just a squared plus b squared equals c squared. All right, Pythagorean theorem, take 3 squared plus -2 squared and square root your answer. All right, and the square root of 13, we'll round it to just one decimal place. It comes out to 3.6. And so the magnitude as a polar coordinate, the magnitude of this vector u is going to be 3.6. And that's how long this is. This is like the hypotenuse of a right triangle, which is its length is 3.6. Okay. Now the last thing I need to find then is the directional angle in degrees. That's where the second formula comes in. The formula looks like this. So all we have to do now, really what we're doing is to find this angle. It's like kind of like we're trying to find this angle theta here. Well, we're just going to do inverse tangent. If this is the opposite leg and this is the adjacent leg, all right, we're just doing inverse tangent. We're going to take inverse tangent of b, which is the opposite leg, over a, which is the adjacent leg. Let's type that into our calculator here. One second. Okay, and you'll notice if you get a calculator, make sure you're in degree mode. So when you do this, you get a weird answer, -33.7 degrees. Okay, well, here's the deal. When you're using polar coordinates, you always want your angle to be between 0 degrees and 360 degrees. So an angle like this doesn't really make sense for us. Here's where this little chart comes in handy. Depending upon what quadrant your vector falls in, there's certain rules you have to follow. Now, our vector, of course, fell in quadrant 4, so the rule is we need to add 360 degrees to this result. We got -33.7 degrees. Since that's in quadrant 4, we're going to add 360 degrees. And this is kind of similar to finding coterminal angles, if you recall. But this is the answer that I want. This is the answer that makes sense, 326.3 degrees. So this is my answer. Now let's graph it, and the graph here should look very comparable to the graph that I got here. So if I start at the origin and go to this angle 326.3 degrees, that's going to be really close to the 330 degree mark. And I count out, if I head towards that direction, a total number of 1, 2, 3, about 3.6 circles, rings I counted out. Well, here is the same vector u, but it's done on a polar coordinate. Well, look, these vectors, they are exactly the same. They both head in the same direction. They both have the same length. Just this is written with its horizontal and vertical component, 3, -2. This is written with its magnitude and its direction. But at the end of the day, it's still the same vector. And there's just certain cases where you need a vector in its horizontal and vertical components because they're actually really easy to add together this way. But there's other situations where you need the magnitude and the direction so you can see kind of which direction is being pulled. Okay, so that is an example of going from polar to, from rectangular to polar. And one more word about this quadrant. The way you're going to decide, if you don't have a graph to look at, the way you're going to decide which quadrant to use is you can really think of this as a point 3, -2. The only quadrant where x is ever positive and y is negative would have to be quadrant 4. But there's different rules. Like if both of your a and b are positives, then that's going to be in quadrant 1. If you have a negative a and a positive b, that would be quadrant 2. If they're both negative, that's quadrant 3. And then if you had this situation where it's a positive and a negative, that is quadrant 4. Okay, so I think that's the harder example of the two, but that's how you do this. So in this example is not on your assignment, but it's a great example to look at. So here we have this magnitude of 5, and we have this angle of 60 degrees. So we can very easily graph this on a polar coordinate, right? I want to find the 60 degree direction, and let me zoom in just a little bit. And I want to count out 5 rings from there. Okay, in 60 degree direction, I'm going to go 1, 2, 3, 4, 5. Here is my vector v that goes a magnitude of 5 in a 60 degree direction. All right, now let's convert. All right, so I have these values. The formula is as follows. Now technically this is like 2 separate formulas, but you can easily put them together into one. So the formula is simply, if I take 5 times the cosine of 60 degrees, that's going to give me my a coordinate. And see, the way I remember this, if you remember on the unit circle, cosine always stood for the x values, and that's why this formula works so well. If I do 5 on my calculator, 5, and make sure you're in degree mode for this, okay? We're using 60 degrees, not radians. If I do 5 times cosine of 60, I get 2.5. Well, that's my a coordinate, and it really couldn't be much easier. Okay. Now to find my b coordinate or my y value, remember sine on a unit circle always indicates the y value or the opposite leg. That's why when you sine in this formula, 5 times the sine of 60 degrees is going to give me my b value. So let's type this in, 5 times sine of 60, and we'll just round this to 1 decimal place. Okay, we'll say 4.3. Listen, it doesn't get much simpler than that. And the good thing about going from polar to rectangular, there's none of this messing around with like what quadrant is it in. No, it's just this really simple, basic formula. Okay, so let's graph this. If I go to 2.5 on my x-coordinate, on my x-axis, well, sorry, start at the origin first. Go to 2.5 on my x-coordinate, 4.3 on my y-coordinate. Here is my vector v. Now take a look. These are the exact same vector. Okay? This vector still has a length or a magnitude of 5. It still goes at a 60 degree angle. This is in polar coordinates on a polar graph. This is in rectangular coordinates on a rectangular graph. All right, I did want to do one problem off of your homework. Let's do the harder ones, okay? Going from rectangular to polar, definitely the harder of the conversions. Okay, so let's do question 3. I got to find the magnitude, and then I have to find the angle measure. Let's start with the magnitude. So the magnitude, I'm just going to do the square root of a squared plus b squared. And this is just Pythagorean theorem. Okay, so anytime you square a negative, that comes out positive. That's going to be 16. Let's refresh. How do we do 4 radical 3 squared? Well, the rule is you square the 4. Okay, it's going to become a 16. But then you also square the radical 3. And remember, radical 3 squared is just a normal 3. Okay, so 16 times 3 is, I believe it's 48. 16 times 3 is 48. 16 plus 48 is 64. Oh, that's going to come out perfect. All right, so ultimately I need to take the square root of 64 here. That comes out perfectly to 8. All right, this rectangular, this vector in rectangular form, it would have a length of 8 if we actually graphed it out. Okay, the length would be 8 of it. All right, now for the angle, the formula is written right up here. I'm going to take the inverse tangent of 4 radical 3 over negative 4. All right, that's going to be a little tricky to put in my calculator, but let me give you some hints here. So I'm going to do inverse tangent. I can just type here 4 radical 3. Now I need to be careful here. I need to, a lot of calculators will give you a parentheses after the square root. I need to close off the parentheses for my square root, but I need to make sure I don't close off the parentheses for the inverse tangent yet. So the 4 radical 3 goes on the top, the negative 4 goes on the bottom, and then I can close out my parentheses for the tangent. Okay, make sure you're in degree mode for this. So it comes out to negative 60 degrees. Now that's not how we want to write an answer. We always want to give our answer as an angle between 0 to 360. So let's look at my rules again. I have to think, where would this point fall in a coordinate plane? Well, remember, if your x value is negative but your y value is positive, that would have to be up here in quadrant 2. A negative x value and a positive y value would have to end up here in quadrant 2. So this is a quadrant 2 angle. So I'm going to follow this rule. I'm going to add 180. I add 180 degrees to negative 60. It's going to be at a 120 degree angle. Okay, which makes sense. You know, if it helps you to make a quick sketch, negative 4 and 4 radical 3, it's going to be up here. So look at that angle. That angle would have to be, you know, between 90 and 180. And it comes out, it's 120. All right, so I hope that helps you. Best of luck on this assignment. Take care. Bye.